Hello friends, in this fourth lecture on singular and double point, we'll discuss another method to find a double point and discuss the problem of finding a position in each of the double points. So another method is let hk be the double point of the curve of the equal 0. If this is a double point, now we'll shift the origin to this double point. Shift the origin to this double point by transformation small x equal to capital X plus h, capital X plus h, and y is equal to capital Y plus k. When we replace x by capital X plus h, y by capital H, we'll get the new transformed equation f of capital X y is equal to 0 of the curve. Since the new origin is a double point, therefore in this transformed equation, the constant term and the term of first degree in x and y must be absent. Therefore, equating to 0 the constant term, coefficient of x, capital X, and coefficient of capital Y separately, equating to 0, constant term, coefficient of x, and coefficient of y separately, we get three equations in h and k. Now, any value of h and k obtained from solving two equations and satisfy the third equation is a double point. So we have to take those order pair which will satisfy the all three equation. We will take the value of h and k, those or h value of h and k which will satisfy all three conditions. Those points will be all called double points. Now so after the point double points, we can discuss the problem by division. So let us solve first problem. Find the position and nature of double point on the curve y square is equal to x minus 1 into x minus 2 whole square. The equation curve is let f of equal to y square minus x minus 1 into x minus 2 whole square. Now let h and k be the double point of this curve. So shift the origin to the h and k by transformation. Small x capital S plus h, y is equal to small x capital Y plus k. Now this equation first, after the transformation, f of x plus h y plus k will become this. Square them, simplify them. After simplification and doing all this work, arrange the equation in descending power of this is square. And now since the new equation is a new origin double point, so we have arranged now. Put the coefficient of constant term and the first term in x and y separately 0. So now this is the first term in y. Constant term is this is constant term red with, and this is constant term. So this sum is equal to put constant 0, and first degree term in x. So term in x is first degree term in x. This is first in x and this is first degree term. So h minus 2 whole square plus 2 into this is equal to 0. And first term in y, that is equal to 2k. That is equal to 2k is equal to 0. So now solve this equation. From the third equation, from this fifth equation, we got k is equal to 0. If k is equal to 0, and from that value of hk, put k is equal to 0 here, and we'll get the, from the equation third, we will obtain two values. H, for this equation to hold true, h is equal to 1 and h is equal to 2. Now the possible double points are 1 0, 1 0, and 2 0. For these points to be the double point, these ordered pair must satisfy the equation, remaining equation, this fourth equation. Substitute the value in fourth equation. At this point, it's not a 0. So 1 0 is not a double point. 2 0, equation satisfied. So 2 0 is the only double point. So we got the double point here. Now, when we substitute the value of h and k in the given equation, We'll obtain 2 0 in the equation. We'll go to transform equation. We'll simply fetch and change this equation. 2 and 0 will obtain equation f of 2x plus 2 y plus 0 is equal to x capital Y square minus x square minus x minus x square is equal to 0. Now this rational algebraic curve in the new coordinate axis in which which passes to the origin. The new origin of the origin of the new coordinate axis is a double point. Double point for therefore for equation of tangents at double point equal to 0, the lowest term in equation 4. So lowest term is y square minus x square is equal to 0. Y square minus x square is equal to 0. This is lowest term. From this equation we got y is equal to plus minus x. Plus minus x. So now we have the equation of tangent in y in terms of x. If tangents are real and distinct, now we'll discuss in about this. So if the tangents are real distinct, so the point 20 will be, what will this? This will be either node or a concrete point. Therefore, in the neighborhood of the new origin, two tangents are real distinct. Therefore, this is a node or a double point. Now, to decide whether it's a node or a double point, conjugate point, node or a conjugate point. Now, if now to find whether the real branch of the curve passes through the 20, solve the equation 4 for y reading the terms of whose power and power of y more than 2. So this question does not have any power more than 2. Therefore, straight away we can solve for y. Y is equal to plus minus x and root of 1 plus x. In the neighborhood of 2, left or right. Neighborhood of 2, left or right, we will get real branch of the curve, real value of y. So this is a point is a node. Now we'll solve this same problem by another method. Another method to solve the same problem. Now this is the question. Find the position edges of the double point. This equation, simplify it. Our simplification, we got f of x is equal to x cube minus y square minus 5x square plus 8x. So now we are solving because the origin of the quantity is not doesn't pass through this. So we have to solve this problem this way. Definition f is 2x, f is 2y, f is 2, secondary f is 2x, secondary derivative f is 2y, and secondary f is 2y and x. 1x is there. Second first step. To find the possible point, put positive f is 2x is 0, positive f is 2y is positive f is 2y is 0, and f of y. Take these equations. From the first equation, positive f is 2x and positive 2y, put them 0, so find the ordered pair for which these equations are satisfied. So positive f is to 0 and y comes out to be, and third equation. So from the equation y is equal to 0 and y is equal to 0 and solve this equation second, we got a 2 and 4 by 3. So possible points are 2, 0, 4 by 3, 0. Now we have to check whether these are the double points. Will they satisfy the equation of the curve, algebraic curve? So x is equal to, put x is equal to 4 by 3 and y is equal to 0 in the f of x curve. So when you solve it, we got that this is not equal to 0, means this 4 by 3 and 0 order pair is not a double point for this rational curve. So another point xy is equal to at 2, 0, at 2, 0, 2, 0, find the value of f of xy. So this satisfies the equation. So 2, 0 is the only double point. We can solve 2 is the only double point. Now at 2, 0, we'll find the value of d. D will find the f is to x, y, or yx at the 2, 0. Send the positive to f is to x and send the positive to z at the 2, 0 and substitute the value in this equation. So after finding the value, we find the value d. D comes to 4 and either d is a node or a conjugate point. So the double point, now we decided it is a node or conjugate point. Now to decide whether it's a conjugate point or node, shift the origin. shift the origin to this point using by transformation. After shifting the origin, we got this equation, same equation which we got in. So now origin shifted to the to 0. So now this equation origin of new coordinates lies on this rational geometry curve. Lowest term put is to lowest term is equal to 0. So tangent comes out to be y is equal to plus minus x. Plus minus x. Plus minus x. What will this decide? This will decide that real tangents are real and distinct. So the again we can conclude that the node is either it's a node or a conjugate node. Real and distinct tangents. Equation 4 does not contain power of y more than 2. Therefore, we can straightway solve y for plus minus x and root of 1 plus x. Equation 8 shows that for small value of x, y is real. Small value of x, y is real. This one is y is real. X means origin 0, 0 of this point. X, what is this? X, y. Origin of this is 0, 0. So 0 origin for this. So for small value of x, so x is very small. It's whether left node of 0 or right node 0. This will be positive. This is very small as equal to 1. So this comes out to be real. So implies for small value of x, whether from the left node to 0 or right node 0 of the new origin of the coordinate axis. Implies for real value of x, we are getting real value of y. Implies the double point, the new origin is not a conjugate point but is a node. Thank you.